Thanks for joining me in today's lesson. In this first tutorial, we will use trig ratios to find missing sides of right triangles. So we are still in section 13.1, and our ultimate goal is to solve right triangles. But before we can do that, we need to build some skills. Let's recall something about the angles of any triangle. The angles of any triangle, the sum of all three of them is 180 degrees. All three angles will always add up to 180 degrees. Now, when we're trying to solve them, these right triangles, I have to give you some information. First of all, I'm only going to give you a right triangle for right now. And we must be given at least one side length and one of the other angles to be able to solve the triangle. One other note about our calculator, we must be in degree mode. It is absolutely your job to push the mode button once you've turned it on and check to make sure that you are in degree mode. So let's show you how to do that. Let's turn our calculators on. Let's push mode. And by default, when you've reset your calculator, it always defaults to radian mode. We do not want to be in radian mode right now. We want to be in degree mode. The angles that we know are measured in degrees. So it's your job to make sure that every time you touch your calculator that it is in degree mode. Second quit, and we'll use our calculator when we need to. Oh, actually that's coming up right now. Here are some examples. Find the trigonometric ratio of the angle. Let's round to 3 decimal places. So we're finding the sine of 26 degrees. All right, well, I pull up my calculator. I push my sine button. 26 degrees will go inside the parentheses. I'll close my parentheses. I already know I'm in degree mode because I just said it. Enter. I'm rounding to 3 decimal places, so I go to the third decimal, which is 8. Look right next to it, and if this is 5 or higher, my 8 goes up. If it's not, then my 8 stays. So 0.438 is it. 0.438. Notice that I used an approximate symbol because we are approximating this answer. Next, cosine of 60 degrees. This is now my cosine button right here. I'll put my 60 degrees in parentheses and I'll push enter. This time I get exactly 0.5. So I can use my equal sign, 0.5. Or if you want to, write it as a fraction, it's equal to 1/2. Lastly, the tangent of 47 degrees. Pull up the calculator, and I'll push my tangent button, that's the third, 47 degrees inside the parentheses, enter, and I have 1.072, correctly rounded. And I used an approximate symbol. This is just practicing, making sure you know how to use your calculator for our trig ratios. Okay, let's look at our examples 4 and 5. The direction says to find the missing angles and the sides of the right triangles using our trigonometry. Let's always round to 3 decimal places. So here's our first example. I have a right triangle, so that's one of the pieces of information. I already have one of the angles. I give you one of the other acute angles, 40 degrees, so we're missing the third angle. Now I know that all 3 of these can add to 180 degrees, so I could take 180 minus 90 minus 40 to get 50 degrees. Or I might know in a right triangle that the 2 acute angles will always be complementary, meaning that they add up to 90 degrees. Either way, this is 50 degrees, and now we have all 3 angles. Let's talk about the sides. I only have one of the sides. It is 8. So I cannot use Pythagorean theorem because I need 2 of the sides to be able to find the third using Pythagorean theorem. So really all that I have now is so, ka, toa. I like to write that down whenever I'm using it. I also need to know where I'm standing. I'm either going to be standing at this 40-degree angle or at this 50-degree angle, and it really does not matter. We'll never stand at the 90-degree angle. We'll always be standing at one of the acute angles. I'm going to choose the one that is given to me because I can't mess that up. I might have messed up my math to get the 50 degrees. I'm pretty confident, but I'm going to choose the one that's given. So I'm standing here. And if I'm standing here, I have the adjacent leg. If I have the adjacent leg, I can use ka and I can use toa. These are the only two trig ratios that use the a, the adjacent. So I'm going to set up a cosine of 40-degree equation, and I'm going to set up, I'll choose a different color, a tangent of 40-degree equation. I'm standing at the 40-degree angle, which is why I'm using that angle, and I'm setting up a cosine and a tangent because those are the ones that use the adjacent, which is what I have. So let's see what the cosine of 40 degrees is equal to. The cosine is adjacent divided by hypotenuse, 8 divided by x. To solve this equation, I might want to put this over 1, because then I can do a quick little cross multiply. I always like to start with the diagonal that has the variable. I know that the cosine of 40 degrees times x will equal to 1 times 8. So I'm going to say x times the cosine of 40 degrees is equal to the other diagonal product, which is 1 times 8, and there we have it. Now I just need to know what x is. That means I can just divide this cosine of 40 degrees away. Cosine of 40 degrees is just a number. I don't know what it is yet, but the calculator will figure it out. And I'm just dividing that number away to get x all by itself. And I'm sure that it's going to be an approximate. 8 divided by the cosine of 40 degrees will be my answer. And let's see what I have. 8 divided by the cosine of 40 degrees. Close that parenthesis, of course. Enter, and I have a side length of 10.443. 10.443. Great. I set up a tangent of 40-degree equation because the tangent of 40 degrees will be opposite y divided by adjacent 8. So y divided by 8. That's what our tangent ratio says. Opposite over adjacent, y divided by 8. Again, I like to put this over 1 so I can clearly see my cross multiply. I like to start with the diagonal that has the variable, so 1 times y will equal 8 times the tangent of 40 degrees. This is actually a little bit easier of an equation because y is already solved for. All I need to do is plug it into the calculator. 8 times the tangent of 40 degrees. Let's see what I have here. 8 times the tangent of 40 degrees. Close that parenthesis. And I have my other side length, 6.712. But because the 7 is bigger than a 5, that 2 has to go up to 3. 6.713. So I found my missing angle, and I found my 2 missing sides. Let's look at my last example. Okay, again, I have a right angle, and I have an acute angle. The other one must add up to 90 degrees with this 33 degrees, so that would be 57 degrees. I have my 14, but I'm missing my hypotenuse and my other leg. I'm going to choose this time to stand here because this is the acute angle that was given to me. And if I'm standing here, I have the opposite leg. The opposite leg happens with the SO, the sine, and with the TOA, the tangent. So I'm going to set up a sine ratio with my 33-degree angle, and I'm going to set up a tangent ratio with my 33-degree angle. I'm standing at the 33 degrees, and I have my opposite side. So the sine is the ratio of the opposite to the hypotenuse, 14 divided by c. Now I have my equation I can go and solve. I'm going to do my cross multiply. C times the sine of 33 degrees will be equal to 14 times 1. Let's divide that sine of 33 degrees away, whatever that number is. And I will have C is approximately equal to whatever this is in our calculator. 14 divided by the sine of 33 degrees. Let's pull up the calc. And I have 14 divided by the sine of 33 degrees. 25.705. 25.705. All right. And my last one, my tangent of 33 degrees. Again, I'm standing right here. Tangent is opposite divided by adjacent. So 14 divided by A. Put this over 1 so I can do my cross multiply. A times tangent of 33 degrees equals 1 times 14. And it looks like that's going to be the same step, except that I'm dividing by a tangent of 33 degrees this time. And I will have A is approximately equal to 14 divided by the tangent of 33 degrees. 21.558. All right. So that's using our SOHCAHTOA trig ratios to find missing side lengths of right triangles. Thanks for watching this, and I'll see you in the next tutorial. See ya.